Hey, Vlad here, devinsid.com. Welcome to another video. In the previous video, we implemented the initial version of binary search trees, and I advised you to start drawing those trees to understand them better. But now, in the next few videos, we're stepping our game a little bit, so we need a better tool for the job. So instead of drawing the trees ourselves, we're going to implement a tiny method on our trees that will render them for us. Also, since the algorithms that we're writing today are getting more and more complex, mostly due to the highly recursive data structure that we're dealing with, I also put together sort of like a recipe for approaching rather complex problems like this. All right, enough talking. Let's start writing some code. As always, we're in the Ubuntu virtual machine, and we have Sublime on the left, and we have the regular terminal on the right, which runs SBT, which runs our tests every time we save the file. Now, before we start hacking on our beautiful rendering algorithms, we need a teeny tiny bit of refactoring to do. So remember when we started talking about pattern matching, I said that pattern matching on sets is expensive because equality is involved. Now, I don't want to go more deeply into this back when I said this, but I believe that now is the time to take a closer look because we can improve things like this. All right, so the first thing we're going to do, we're going to go to the equals method, which is over here, and what I'm going to do is I'm going to wrap this with curly braces like that. Right, so that we just have a scope to working, and I'm going to let Scalar format it for me, and over here I'm just going to print line equals, and this way I'm just going to know whenever equals is called. So and I'm going to switch from running tests to running a main method that we don't even have yet, like that, run. Okay, so I'm just going to go down now, and I'm going to start introducing a tiny main method. So main extends up, let me scroll down a bit. Okay, and as you know, I like my hyphens times 50 like that. All right, print line hello world, just to make sure that everything is working as expected, and there we go. All right, so the idea is just to see when the equals method is invoked, right? So we're just going to create a set. I'm going to call it some set, right, because it doesn't really matter which one. So we're going to start with an empty set, okay? And what I'm going to do is I'm going to start pattern matching on it. So I'm going to say match case underscore, right? And I don't even care what's going to be on the right side. It's going to be unit. So all I want to see is if equals is going to be involved. So in other words, if we're going to see the word equals printed out, right? Because we put the equals print line into the equals method. All right. So this one seems to be fine. So the wildcard seems to be fine. Let's do something else. Let's do some set match case set dot empty, and also case underscore like that. Now notice that empty is private, so we need to go and make it public just for this video. This one, and not this one, but this one. Okay, like this. Let's see. All right, now it looks like in this case it is actually invoked. In fact, you know what I should do? I'm just gonna go here and say no, and I'm gonna go here and say yes. Okay, and then we actually can comment it out so that it's easier to see if the next code that we're going to write actually invokes it or not. So the next one is going to be non-empty like this. We're going to have left element and right arrow to the right, and we're going to have the empty case as well, not the empty case, the wildcard case as well. All right, what does it say? Object not empty and object set cannot be accessed in object. What? I thought I just made it less private. Oh yeah, I forgot that we still have those pattern matches. Let me comment this out, and this one as well, the unapply, because remember these were supposed to prevent us from pattern matching. Okay, so it should be fine now. I think I got all of them. All right, so this one seems to be a no as well. No. All right, let's comment this out. Let's do the next one. So we're gonna go with some set match case set non-empty. So now in this case we're actually going to use set empty over here, then we're going to have element right. Okay, and let's see underscore. I'm using the wildcard just so that we don't have the warnings that the match is not exhaustive. All right, okay, so it looks like this one is fine as well. Okay, no. All right, so let's keep going. In fact, I'm going to copy that. I'm going to paste that over here. The next case is going to be that we're using left over here. And we're using set.empty over here. Let's see. Okay, it's still no, so I can actually leave the comment. And the next one is going to be where we use empty twice, here and over here. Right, let's see. All right, so this one also seems to be fine. Now let's gonna do this whole exercise again, but this time with a different set. So instead of using an empty set, we're just gonna use a set with one element, right? So we're gonna do one element, and we're just gonna repeat the whole game. Okay, so let's do the wildcard. Seems to be a no. Okay, so that's fine. Okay, let's do this one. Yes, all right, that was expected. Let's keep going. So this is supposed to be a no, right? Okay, it's still no. That's all good. Okay, what about this one? All right, that one changed to a yes. Okay, so I'm just gonna say yes. In fact, I'm gonna remove the no because it depends on the input, so it's a yes for us. Let's see. Probably the other two are also gonna switch. Let's see. Yeah, this one is yes as well. And let's comment this out. All right. Let's see for this one. Oh wow, we're seeing it actually twice. So every time, it feels like every time we're using empty, then the equality is involved. And this is exactly what I sort of tried to prevent. In fact, look, if I switch to running tests, because the tests, they go through the entire set, right? We don't need the print line anymore. Not this one. This print line. So we can revert that pretty much. Okay. Let me do it like that. All right, so the primary reason was to gain a bit more of performance, but also look, if I go into fold and I start instead of this, I'm gonna start doing empty, right? So if I do that, look what's going to happen. So if I'm red, then it should actually explode with a Stack Overflow error, because what happens is that fold is asking if it's empty, and empty is asking for equality, and equality is asking for subset in both directions, and a subset is calling fold again, right? So we get a Stack Overflow. So this was yet another reason. So it seems like using pattern matching for the empty case is a bit dangerous, but using pattern matching for cases like this is not. So what we're going to do is we're going to implement an extractor for the empty case that is not going to involve equality, and we're going to use it instead. So we're going to do that instead of empty. So it's just going to be an extractor that returns a boolean, right? And for these, we're going to rewrite the pattern match in by using the constructor pattern. So let's just do that real quick. So I did not save the file yet, right? But we can go down. So I'm actually going to remove the main because we don't need it anymore. Like that. We're still running the test, but if I save the file, it's just not going to compile. So everything that I commented out here, we're just going to throw out like that. We don't need those prevention mechanisms anymore. In fact, this one we're actually gonna keep. We don't need the coverage for now, at least. So we're gonna keep the unapply. All right, we're gonna put it over here because this time we're actually gonna use it. We can switch back the private stuff. We can turn it back on. Let's throw this out. All right, and also enable this one. Okay, so in this case, we actually want to implement something for an unapply that is actually helping us. So in this case, we're just going to return a boolean. All right, so we're returning a boolean, and all we're going to do here is we're going to say set, and also I'm going to have a set over here. Actually, I'm going to say that it's only going to match sets, set of element. So I'm going to say set is instance of empty dot type, and it's not going to be private this anymore. It's going to be a regular extractor, and I'm going to also include a Java doc like that. Okay, simply saying that case empty causes stack overflows in methods like fold. Case empty does not, and I'm gonna let Clariform fix everything for me. It says element does not exist, so we're just gonna include it over here, element like that. So I forgot that. Is instance of is not a member. Okay, this is usually a typo. Okay, there we go. Oh, set is instance of. All right, so remember that we're using this already. over here in default, so now it doesn't cause any Stack Overflows, right? So what I'm going to do now is every time I'm doing that and that over here, I'm just going to press Alt F3 and it's going to mark 3 instances. So I'm just going to say case empty, arrow to the right instead. Okay, so what's left to do is to find all of these cases, case not empty set, like that, and change them to case not empty left element right. Okay, so I just now need to go to through all of these places and remove that like that. Okay, because now we have left in scope, element in scope, and right in scope, and this should not be right, this should be right. I mean, we can call it however we want, but let's not confuse everyone. All right, so let's hope that we found, okay, I forgot the arrow as well, hold on, like that, and we want the arrow, and there we go. Okay, obviously we still have many mistakes, so over here, not empty set dot, I'm just gonna do that. Okay, that should be better. Okay, so we're down to 19. Over here, same thing. Wow, many over here, right? So our code is actually getting much shorter because we're using the proper pattern matching. Okay, only 11 left. Over here, not empty dot. All right. Now it actually fits into the screen. All right. Okay, 44. Let's see over there. Not empty set. Oh, okay. So what we had before here was not empty set at not empty. But it turns so we can actually leave it like this if you wanted to. But it turns out that we actually don't need to. We can actually return this, I believe. Let's try to return this. Yeah, it's still green. So it's basically the set it is the case when we're adding something to the set and the element already exists, so we can just return the set as it is. Okay, so okay, so now we fix all the cases. Our pattern matches look more beautiful. Let me look through that real quick. Yeah, everything still seems fine. So what I'm going to do now is I'm just going to commit it. So I'm going to open just another terminal over here. I'm going to go to dev homegrown collections and I'm going to say git status. I'm going to add everything, even though it's already added. I'm going to say git commit -am, and there's going to be video 10 pattern matching refactoring. Okay, like this. I'm not going to push it. I'm just going to push it once in the end of the video. Okay, so if I do git status now, it's going to say, okay, there are no changes. Everything is fine. So now we can actually start implementing the rendering method. All right, so I also promised you a sort of like a recipe of how to approach slightly more complex problems like this. And some of the points on that list are going to be highly hypercritical, because even though I put this list together, sometimes I sort of jump into problems like this, and you know, I'm become sort of like a bit less professional, because I just want to hack. You know, sometimes, you know, you have this passion for just start working it. So in any case, let's just start with a list. Number one, assume that the problem is rather complex, right? So you know, programmers seem to be always in this desire to have this desire to prove to the world that we're, you know, the smartest people on this planet, right? So we sort of look at problems many times, and then we just think, it should be easy, and then we just jump in and start writing code. So this is an exercise for your and mine arrogance, right? So every time you're confronted with a problem, you know, take a step back and assume that it's more complicated than you think. Number two, this is probably the most important one, understand the problem. And I'm not talking about the solution, understand the problem. For example, in our case, we're going to be rendering strings, right? And every time you're doing some sort of rendering, something was interfaces, something was your user experience, you know, think through the edge cases. For example, you know, also like, what do you want to achieve? Like, how's it going to look for really big trees? How's it going to look for really small trees? Should it look the same? Should it maybe look a little bit different? Should we render like small trees like one way and big trees the other way? Number three, don't just understand the problem, also understand the solution. Now, this is not, you know, you're not studying right now, right? So this is not a test. So I assume, like, you know, when I make videos like this, I assume, you know, that you want to become a professional software developer. So you are at work, you're confronted with a problem. Most likely, this problem has already been solved. It's not there's nothing wrong with you know, looking at the approaches that other people have taken. In this case, I'm actually going to show you this in just a few minutes. There are different, there are like 5 or 6 at least ways to render trees, and we're just going to pick one of them. Number 4 is kind of simple, write tests. You don't necessarily need to test drive your thing. Like sometimes, especially for things like rendering, TDD is not always the best way to go, in my opinion. You could use something like BDD, where you basically outline all of your tests first, and to see like how the big trees are going to be rendered and how the small trees are going to be rendered and so on. And then the step 5 would be to just reorder them and maybe comment all of them out and order them by simplicity, and then maybe start test driving it. Tests are going to be really, really important for this one. Whatever you do, you want to minimize the so-called feedback loop when you're solving problems like this, right? So I'm actually going to make an entire video just about this topic alone. So it's basically how fast can you get feedback from your solution, from your assumptions. Okay, so we're going to start by taking a look at a few problems, not a few problems, but a few possible solutions. So I have 3 links open here that are just simply Googled by by searching for toString for binary trees, or binary trees rendering or something like this. So one solution would be something like this. So basically the last row is gonna contain one row of slashes, and then the previous row is gonna contain 2 rows of slashes, and then the previous layer is going to contain like 3 layers of slashes, and so on and so on and so on. We're going to scroll down a little bit over here. So we're not looking at code yet. We're still researching the problem, so to say. Another way would be to just say, okay, we're on level 1, and then surround your elements with brackets, and render the tree like this. Another solution would be to render it like that. So essentially, we'll generate a bunch of spaces. Another ones are, this is similar to the one that we've seen before. Another one would be like that, right, with those weird dots and other hyphens as well. Over here there are some pluses involved, right? And the third, not the third, but the third tab, but yet another solution would be to render trees like this. So the others were sort of vertical, and this one is like a bit more horizontal, or actually the other way around. Like it depends how you look at it. So the trees are usually vertical, right? But over here the tree is actually going to be rendered like horizontally, right? So yeah, so just the fact that there are so many solutions out there sort of shows that my recipe is not that bad, right? So just research your problem space first, and then also research your solutions. So for example, now you can start looking at the code, and it's not always the perfect code. You never know where you find your code. You never know what person wanted. Maybe this person didn't have time to write a proper solution. What happened to me, for example, I had a Stack Overflow answer to a question that I had like when I was studying. So I had the solution from like 5 years ago. I just made sure that it compiles. I didn't really care about how perfectly formatted it is or whatnot. So I just threw it in there, and it helps someone, right? So don't judge. Like every time you see the code, don't judge. So for example, this code, it looks a bit more involved. I'm not sure. Maybe it can be simplified, maybe not. But it sort of scared me away a little bit. So I was like, hey, maybe this is not the easiest way, because I thought. Okay, the trees, they seem to be like sort of symmetrical, but the problem is it doesn't seem to be very symmetrical, because we're printing out things, so we need to have like \ands over here to break the lines. Also, before we would need some space, so this is not sort of symmetrical. So I kind of assume that it would be hard to figure out the places where you need to insert the break lines, right? For example, you need to figure out, okay, so I'm on this layer, on the third layer, and on the third layer the maximum number of elements would be 7, and this is the 7th element, so therefore I'm going to have to insert the \n, something like this. I was like, I don't want to do that. Other solutions also depends on the language that is being used. Okay, so this here, it looks like C, and there's a lot of code involved, so I was like, no, there's no way in hell I'm doing that. Then I looked at this one, and this one seemed kind of tiny. Right, so I was like, okay, I'm gonna do this one. So we're actually gonna implement this one. So let's start. So there's an application in Unix called tree, and you can install it by just saying sudo apt-get install -y for saying yes to everything, just tree. I believe the y should be capital. Okay, it's not capital, so it's small. All right, y. All right, tree. Okay, so now that it is installed, in just a few seconds it should finish installing. All right, so now I can, for example, go into my folder, into dev, homegrown trees, homegrown collections, and I can go into source, right? And I can type tree, and it's going to render it like this, right? So notice that this tree is not a binary tree, right? So for example, one node, which is a folder, it can contain more than 2 files, right? Well, what you can notice is that, first of all, some weird ASCII characters are being used. For example, for an element like this, there is a character like that, and there are 2 hyphens. right? So this seems to be the last node. So the last nodes are rendered like this. Okay, the last nodes are always rendered like this. So and if the node is not the last node, then it's rendered with a character like this, and then with hyphens like that. Okay, so this is what we're going to do. Basically, our trees are going to end up looking exactly like this, but we have a binary tree, so our code is going to be teeny tiny bit simpler, because all we need to do is we need to figure out, okay, are we rendering the right node or the left node, and then basically to do either this or that. Okay, so before we start, there's this website that I discovered called I mean, there are many websites. Let me just go there. It's called compar.com and unicode. Okay, so you can just take you can just grab a character like this one, for example. Right, so I'm just going to right click, I'm going to copy, and whoops, that's the wrong one, and we can search for it here, and it found it. Right, so obviously we can just copy paste it into our editor, but we could also use the unicodes. Right, so if you use this one, right? So if in our Scala code we will have a string like that, and we can just say \u, and then we can say 2514, because this is the code, it will also render this character. But we actually don't need to. We can actually straight copy paste this into Sublime. So this is all the prerequisites that we need. So let's just start doing this right away. Okay, now because this method is a little bit more related to trees than sets, we're actually going to go to the test folder where we have the set suite, and we're going to create another one called tree suite. Like ideally, we would also rip out this render method that we're about to create straight on sets. Ideally, we would create it on something something different. Oh, did I just create a folder? Oh my god, why did I create a folder? Delete that. Oh, come on. New file. There we go. All right. So it's going to be tree suite.scala. All right. So we can go to set to the top of the file like this. Okay. Not the sets. I'm sorry. To the set suite. Okay. Top of the file. Just copy all of that. Go to the tree suite. Insert tree suite. Okay. So we can close the brace over here. I'm going to close the set suite. I'm going to open the set. Right, and I'm gonna put the set down here. Okay, so we have the set at the bottom here, and we have the test over here. We just have a test. I'm just gonna call it main, just to see that it's working like this, and I'm gonna say 1 should be 1. It's sort of like a hello world. And over here in SPT, I can actually run only test only tree suite. Right, and if the test already compiled, then I also have auto completion. Right, so I can keep compiling, just keep running only these tests. Okay, which is kind of cool. Okay, so it's working. Okay, so today we're gonna have only one test, but it's gonna be a big one with a lot of assertions. So now what we're gonna do is we're going to start by just printing out our hyphens. Because here's the thing, like when you test drive something, usually your test framework is going to print out things for you. It's going to say, okay, expected did not match actual, and this is why. It's going to start, showing you like which characters are different. But in our case, this is not going to be enough. So what we're going to do is we're going to create a helper called test rendering. Right, it's going to be just a tiny function that is going to take our set, and in the beginning it's going to be the empty set, and it's going to take the expected result. And what it's going to do, and it's going to be defined over here, private def test rendering. How did I spell private like this? Okay, there we go. Okay, so what test rendering is taking is just a set. What's happening with me today? Set, which is a set of any element. We don't really care, and I'm going to make it a curved function. Just to make the tests look nicer. You're going to see in a second why. Okay, so we're giving the expected string. I don't care about the return type. It's going to be something that Scala test needs. And what we're going to do is we're going to have actual, which is just going to be set.rendered, and set does not have the rendered method, so we're just going to go and add it. Let's go to toString maybe. Okay, toString is defined over there. Is it also defined? Okay, so I'm just going to put it over here. So I'm going to say final def rendered, and it's going to be a string, and for now it's just going to be empty. Okay, so we're calling set.rendered, and then we're going to be printing out something in yellow, and it's going to be the actual value. Right, this is going to be our code, what our code is producing. Right, so we're just going to print it out, and then we're going to have a few more hyphens times 25. This is exactly what I meant by minimizing the feedback loop, right? So then we're gonna print out in green what we expected. All right, so this is the actual one and this is the expected one, okay? And let's do the hyphens again, but this time the whole 50. So in this case, when we see like the small hyphens, we know that we're sort of in the middle of one rendering thing, right? So what I wanted to do, I wanted to render what the actual was and what I expected. You know, the actual one is going to be in yellow and the one that I expected is going to be in green. And then it should also automatically compare them, right? It's just strings, right? So just say actual should be expected. So what happens is that, you know, if our test fails, right, it means that the exception is going to be thrown over here, right? But I'm still going to see those print lines. So the last print lines that I'm going to see are going to be basically the test that failed, okay? And then because we have only one test, it's just not going to continue. Okay, so let's just run it for now. And it looks like this. So we expected the empty one, right? I'm sorry, this is the actual one. So the first one is the actual. We wanted it to be empty, and it was empty. Okay, so let's just keep writing our tests. So over here we have test rendering for set empty. Let's add another one. Let's go for test rendering of set of 4. So this is one. So this is a singleton. This is a set that contains only one element, which is 4, and we want the rendering to look like this. Actually, I don't want to use the string interpolation. Okay, so what I'm going to do is I'm just going to copy it from what I prepared. But you can also, you know, you can copy this character from this tree program that I used before. Now I have a plugin for Sublime called Highlight Dodgy Chars. So it highlights the characters which are not ASCII, right? So basically like weird Unicode characters. So what I can do is I can go over here to Preferences, Package Settings, Highlight Dodgy Chars. I can open the default settings. I can copy all of them. I can close it again. I can go to Preferences, Package Settings, Highlight Dodgy Chars. I'm going to go to Settings User. I'm going to paste that, and over here what we see is whitelisted characters. So what I'm going to do now is actually I'm going to make it large. Okay, so I'm just going to have a comma here because this is just a simple array, right? So this one, these ones, and the ones that we're going to insert right now. So the ones that we're going to insert right now are going to be this character. I'm going to have a space now. Then this character over here, and pipe. We technically don't need spaces. I'm just separating them like this so that it's easier to see. And also this hyphen. So this is not a regular hyphen. Like a regular hyphen looks like this. Okay, this is this weird hyphen, right? As soon as I save this file and maybe reload it, yeah. So now we don't see this weird stuff, and in our test we also don't see this weird stuff. So what it allows you to do is, as you have just seen, we can take them and combine them together, right? So if we do this, right, and then we take a hyphen, I'll put it here, right? Then it starts looking like this. If we take that one, you know, put it here, then take the hyphen, put it here, then it looks like this. And this is exactly what we need. Okay, so now that these characters are whitelisted, our tests actually look beautiful. Okay, so now if I run this test and I press F11, then I'm going to see, okay, this empty one passed, but this one didn't. So the actual was empty, and the one that I expected was this one. So this is the time where we actually start, the first time where we actually start implementing this this code. All right, so the first thing that we're going to do is we're going to have a scope here. Okay, and we're just going to have a pattern match, this match. Okay, so if this is an empty one, right, then let's just leave it empty. Otherwise, if it's a non-empty one, non-empty was left element and right. Okay, so it seems like what we want is we want this, and this is a string, and there's a space, and we want plus element. So the idea is that the first element that we're going to print, the root of the tree, at least in the beginning of the implementation, is going to look like the left node, and the left node is not going to be the left node is going to be the last one, right? So we want it, so the tree is vertical, and if we put it like to the side, then the right node, I want the right node to be above, and then the left node to be at the bottom. And because it's at the bottom, it has to be this the one was the corner, right? And in the beginning, the root node is also going is always going to seem like it's the left node, right? Even though technically it's not left. We're going to fix it actually by the end of the implementation. All right, so let's see if this is already enough to make our test happy, and it seems like it is enough. Okay, so this was the actual one, and this is what we expected, so they're all the same, and it's all good. Okay, so let's try the next one. So we're going to have test rendering, and we're going to have a set of 4 and of 3. So this is what I meant was sorting your test by complexity. So what we're going to do now is we're going to go 4, 3, 2, 1, right? So it basically means we're creating just left nodes. So all we need to care about right now is how to render left nodes. Okay, so 4, 3 should look like this. And this is where we're going to start using fancy string interpolation, right? Like this. So we're going to have this, the 4, okay, and then we're gonna have over here, we're gonna have a bunch of spaces like that, and we're gonna have the 3, okay, and this is where it ends. Right, so if you remember, strip margin is going to make sure that that every line starts where those pipes are starting, and it's going to remove like this whole margin. So everything over here is going to remove. Okay, so this is what we're expecting, and let's see what it is actually rendering. Okay, so we expected this, but what we got was just 4. Okay, so what we need to do is we need to look at our code, and we need to figure out, first of all, we need to break the line. Okay, so it seems like we need to do something like this, right? \n, okay, and then we need to do plus, and then we need to do left that rendered, and it seems that we also need those spaces, right? So we sort of want to tell it to take 4 spaces, right? But if we look at rendered, it actually doesn't take those spaces, right? So we want something like this. Now every time you're confronted with a situation where you sort of want something like this, but you know the signature just doesn't allow it to you, you just need to break a boat, right? So what you do is you just wrap this thing into something that you call, I don't know, loop or something, right? So this will take the initial set, right? It's going to be called set element, and it seems like we need this thing, and this thing is going to be called a prefix of string, right? So essentially this thing is going to do what rendered was supposed to be doing, right? So just going to wrap that, the whole thing over here like that. I'm going to move it to the right, okay? And now at the bottom we just need to call loop. It's sort of similar to the tail recursion that we were doing. Okay, so in the loop, we're just going to specify the prefix, and in the beginning, the prefix is simply an empty string. Prefix is going to be an empty string, all right? And our set is going to be simply this. So over here, when we're matching on that, we're just going to do set. Okay, so let's see if it actually already works, at least, or at least if it compiles. Okay, left.render. Okay, so we're still calling left.render instead of loop. So let's call loop, and the first parameter is the prefix, and the other one is the set. So the set is going to be left one, right? So we want to keep printing out the left one. Okay, so what's happening now is that the test that we even had before that was passing, you know, where we're just printing out this one, right? Just a 4, it is not working anymore, because all of a sudden there's this hyphen, not the hyphen, the break of the line over this, right? For now, we can just fix this problem by just always dropping the last character. We can say drop right. Whatever comes back here, just drop the last character. We don't really care about it anymore. Okay, so it seems like this test passed again. This one did not pass again. And now this is exactly why we did this. Now we can visually see what is happening. Okay, so what's happening now is that we're actually not using the prefix, right? So we're passing it in, but we're not using it anywhere. So it seems to be that we need to insert it before we're doing this, right? So let's just do this. Prefix plus, right? So in the beginning, in the first row, it's going to be empty, right? So it's just not going to insert anything. But in the later point, it's going to insert. It's going to insert it, right? So these 4 hyphens. Okay, so it seems that everything is passing, everything is green. So let's copy that one and do one more node. 4, 3. Let's just keep going with the 2. Okay, so I'm just going to press enter over here, right? A bunch of spaces. I'm going to have the 2, and before the 2, I'm going to have that, like that. Okay, so this is what we want, right? 4, 3, 2. Let's see. All right, so we wanted this, but again, it seems to be that we're not using the prefix enough times. So when we're rendering the left node, we actually should also use the prefix. So we need to use the prefix as over here as well. Let's see. And yes, in fact, it is enough. Let's try one more. Let's go until the 1. 1. So let me press enter over here. Do that, like that. It's going to copy that, paste it over here, and now it's just going to be 1. Very careful with your test. Do not make mistakes in your test. This is like the worst thing that you can do. All right, so it seems like where we're done was rendering the left part of the tree. All right, so the first test is going to be pretty similar to this one. So we, instead of printing out 4, 3, 2, 1, we're going to start printing out 1, 2, 3, 4, right? So I'm just going to do 1, 1, and this one should pass because it doesn't matter if we're printing out a 4 or a 3. But the next one, so if I copy this one, right, if I insert it over here, right, so it's not going to be 4, 3, it's going to be 1, 2. Right, so I want to have 1 here and 2 here, but remember I want to render the right nodes differently. I don't want to use this character. I want to use this character over here that I'm going to copy paste over here. So this is how I want to see the right nodes being rendered. Okay, so first of all, the right node is not being rendered at all, right? So we're not even seeing the two. So I'll just do that. So let's just add it. Okay, so I'm just going to do that. So let's just do the same thing with the right nodes. Okay, let's see. Okay, now it seems to be rendered, but we're not using the proper character, right? So all we need to do, it seems that we need to figure out if we are, if we're doing the left node or if we're doing the right node. And by the way, this is only so simple because it's a binary tree. If it was not a binary tree, what we would need to figure out is, are we printing the last node or not? Right, so the last node in this layer, in this depth, in this height, whatever. Okay, so assuming that we had a method over here, right? It's going to be an inline, not an inline, but like it's going to be inside of rendered. It's going to be called left or right, and if we're passing it a boolean, which is usually not an ideal thing, because this basically implies that the method is doing 2 things instead of 1. But in this case, like this is exactly what I want. So I want to say, okay, if it's a left one, then I want to render this. Like that. Basically it's this one. This is the left one. Okay, left ones are gonna be like this. Otherwise I want this one. Right, so all we need to do is we just need to call it over here, left or right, right, and we need to pass it the is left, but is left is not even here, so we're just going to add it, right? So instead of just having the prefix and the set, we're also going to add is left. So I left the prefix as the first parameter, but I want to keep the set as the last parameter. I left the prefix as the first parameter because it's a prefix, right? It should be the first one. So is left, I'm going to put it over here. So is left is going to be a boolean over here, right? So as I already mentioned in the very beginning, is left is going to be true because I said that the very first node is going to be rendered as the left node. So we're going to say is left is going to be true. And then over here, every time we're calling the loop, now we have to specify are we rendering the left one or the right one. Okay, so over here I'm going to say is left equals true, is right. Sorry, is right doesn't exist. Is left equals false, and I believe this should not work because Scala doesn't like that. Oh yeah, no, it's fine. I thought that the named parameters should be the last ones, but it's actually fine, and it actually fixes our test. Okay, so every time we're rendering, because like this is like one of the problems with those trees. Like once you're in, like, as a parent, you know what's on your left and what's on your right, but as a child, you don't know, are you on the left or are you on the right? Therefore, we just need to keep passing this extra information. This is one of those slightly complicated things that you will figure out if you keep doing more of these algorithmic things. So it's just like it's like one more tool in your toolbox. All right, so let's keep going. Because we're actually getting dangerously close to an hour video. Let's not have that. All right, so the third one is going to be like this, right? So I'm just gonna copy that. I'm gonna paste it over here. And as I said, very important, do not make mistakes in your test. When we're rendering the right nodes, we wanna have hyphen over here. Instead of the space, we wanna have the hyphen. Okay, so this is how we wanna say that. Okay, so this is the right node and there will be something on the left, right? There will be something on the left, right? So if this node had something over here, we would need to continue with this line. Okay, so let's do that. Okay, so this does not pass, right? Because exactly this thing is missing, right? This hyphen is missing. So it seems that instead of just calling left or right, we need another one called is the parent left or right? So I'm just gonna copy that. I'm just going to paste it over here, right? And I'm going to say left or right parent, okay? And if it's left, then we're just going to have spaces. It should be 4, 1, 2, 3, 4, right? And if it's right, then it's going to be this pipe followed by 4 spaces. Okay, now all we need to do is we need to call this left or right parent over here, right? So instead of these, I'm just going to call a left or right parent, and I'm just going to pass is left, and that should fix our test. Hold up, is left, like this. I believe that should be fine now. Yes, this fixes our test. All right, so the next one should not be a failing one, so we're just going to do, because we started with a 4, it's going to keep going like this. So press enter over here, right? Go over here like that, and copy that, paste it over here. Nope, like this. Very, very important. Be very careful with your tests. Go slowly. So we need the pipe over here, and we need the pipe over here, right? So, and this one actually should pass. I don't think that we need to change anything. All right. So it seems like we're perfectly capable of rendering purely left trees and purely right trees. So now let's start mixing them. Okay. So this one is going to be test rendering. Set off. So let's go, instead of 1, 2, 3, 4, we're going to go 1, 3, 2, 4. Okay. Now 1, 3, 2, 4 means 1, the 3 is going to be on the right, the 2 is going to be on the left of the 3, and the 4 is going to be on the right of the 3. Okay, so I'm just going to copy that. I'm going to paste that over here. Okay, so again we have 5, we have a 1, and then we have a 3 which is on the right, which is fine. Now we need to have a 2 on the left and the 4 on the right, so it's going to be something like this. Okay, so the 4 needs to be on the right, so the 4 actually needs to be over here, and the 2 needs to be over here, and because this is the left node, we need that one over here, right? So it's going to be something like that. Okay, so it needs to be something like that. So we have 1, and then on the left we have the 3, on the left of the 3 we have the 2, and on the right of the 3 we have the 4. Okay, and let's see. Okay, this failed, and it seems like everything is fine except for these. So what is happening is that we're printing out the left node before we're printing out the right node. So this is happening because we need to switch these, right? Just switch these, and I'm gonna go to end of the line and have a plus over here instead of over here, and this should actually already fix the test. All right, so this is fine now. Okay, so now just for fun, because we're pretty much done, I'm going to also paste a few more fun tests like this one. So this is how a 1, 3, 2, 4 minus 1 tree should be rendered, like that, and also a slightly bigger one, like that. Okay. Right. So the next thing that we're going to do is, first of all, we're going to improve this first one because I wanted, I sort of want all of them to look kind of symmetric. So I'm going to do this, sorry, that. Okay. I'm going to start it with a pipe, and I'm going to do that. I'm going to say that strip margin, and I'm going to do the same thing to the test with the 1, just over here, right? 1 over here. Everything should still pass. Okay, and this is the moment where we're going to go back to the original tree, right? Tree program, and we're going to go to the source, and we're going to do tree, and we're going to notice that the root node is not rendered as a left node, right? It's just rendered like this, right? So it's just basically it's starting like this. So this is what we want to do, right? So basically every time we're saying this, I just want to say 4, right? I just want to say 4 over here, over here, over here. Whoops, actually this one was wrong as well. Hold up. It's like that. So if I hold shift and I use the right mouse key, then I can actually mark it as like that and remove that. Okay, so mark the 4 of them like that. So this is how I want my trees to be rendered, just to save the space, and it's going to look a bit more beautiful, right? Like that. Fixing all the tests. Okay, there we go. And obviously none of that is going to pass. Okay, so what we need to do is we need to figure out are we rendering the first node or not. So there's going to be yet another character, not a character, another parameter, which is going to be called isFirst, which is a boolean, okay? And is first is going to be true in the very beginning, okay? Is first is going to be true in the very beginning, okay? And over here, every time we're rendering something else, is first obviously is going to be false, right? So we have this is first parameter, and where we're going to use it, every time we're doing this left or right thing, okay? So this is left is not only getting the is left parameter, it's also going to get the is first parameter, okay? So we need to take this is first parameter and also introduce it in both of these, right? Both of these like that, okay? And all they need to do is, and they need to say if is first, then just do nothing. Otherwise, do whatever you were doing before, right? So I'm just going to copy that, put it over here as well, and I believe that should be it. Okay, so our trees are perfectly fixed now. The last thing that we're going to do is we're just going to remove this drop right, right? So we're just going to remove this drop right because it doesn't harm if we have a you know, an empty line at the end of every test, right? So what I'm going to do is I'm just going to press. So every time I have this strip margin, I'm going to mark all of them. I'm going to go here. I'm going to do pipe like that, and that should fix all the tests, I believe. Yep. Okay, so like that, like that, and yeah, all of that should be fine. Okay, so now I'm going to maximize Sublime so we can have a quick look on the tests, and we can also look at the entire algorithm if I do that. Like this. In fact, let me just do that. Okay, so now we have the rendered method. It looks kind of big, right? And you know, it kind of looks intimidating. So if you just find it online and you look at it and you're gonna be like, what? Why is it like this? So this is one of the advices that I also want to give you, is that, you know, every time you encounter code like this, which might have been written even by past you, and you know, you just have forgotten, or maybe by one of your colleagues, and you're you know, sort of having problems understanding it, simply start writing tests. First of all, assume that it's doing the right thing. Right, you know, maybe if you have documentation, good. You know, if you don't, just start writing tests, right? The test will reassure you that your assumptions are correct or not. Okay, so the only thing that is left to do is to commit the entire code, and before we go into commit it, I'm going to comment out the print lines. All right, so in this entire test, we're using this. So I'm just going to go over here and I'm just going to do that. So I still want the test to run. I just don't want to see the print lines. Okay, so if one day I want to see them, I'm just going to go in and I'm going to comment them in. But for now, I want to comment them out. All right, so now we can exit the console actually, because we don't need anything. And actually, the last thing that we want to do is we want to run all the tests, and all the tests seem to be still green. Okay, so I'm going to exit SPT. I'm going to say git status. Okay, git add everything. Git commit -am, and this is still video 10, right? And it's called rendering like that. Okay, and now I'm gonna push it, and I should unlock my key. All right, there we go. Okay, so let's look at it online real quick. Okay, so we have pattern matching and refactoring. Pattern matching is over here. See, we touched like almost everything. This is exactly one of the reasons why you don't want to mix these commits with the actual changes, because if you look at the actual change, it's going to be much more. It's going to look much more surgical. It's going to be okay. You added the rendered method, fine. You added the tests for it, so you can clearly and easily review this pull request if it was a pull request. All right, one last thing that I'm going to tell you before I go. I found this solution online. Unfortunately, once I implemented it and wrote all of my tests and prepared the whole video, I lost the link. I really wanted to give credit to the original author, but I couldn't, so I'm sorry. All right, that's all I got for you today. Like this video if you did, subscribe if you want to improve the developer inside you. Most importantly, take care.